Hey, y'all, what's up? Let's do some arithmetic-y stuff today. This is actually kind of fun. This is a little bit of geometry as well. So I love how Saxon sticks this in there and kind of mixes it all up instead of telling you to take a year off of your life and take geometry as a whole separate year anyway. But let's look at an oldie here. You tell me what the method is to solving something like this. You cross multiply, right? And in other words, I'd just go ahead and do this part times p to get, I'd go 5 over 7 times p is equal to 4/3 over times 8/11. So 4 times 8 is 32, 3 times 11 is 33. Then you're going to multiply by 7 over 5, reduce, there's your answer, okay? I don't care what it is, okay? Well, there's a slight change today, a slight one, and this is what it is. You tell me what the slight change is. The slight change is that we have a purple header. And the change is, of course, these are mixed numbers, okay? Which, again, a lot of the stuff we do for the rest of the year is making new-looking stuff look like old stuff. And you only have to do one thing to make this look old. And that's to just like put glasses on it and gray hair and wrinkly skin and, those shoes that are like, those orthopedic shoes. Okay, no, that's not, okay, forget that whole thing. I don't know, you guys are actually kind of weird here. Okay, anyway, all right, let's just change this whole thing. Maybe we'll do it all at once. 4 over 9 over x equals 2 1/5, the heck with that. That's 11/5, right? 1 3/4, 7/4. Boom, okay. Cross multiply, 11/5 times x equals, well, we got 4 over 9 times 7 over 4. Oh, the 4's cancel, right? That's going to be 7 over 9. Now a piece of cake, multiply by 5/11. And x is equal to what? 35 over 99. There you go. All there is to it. Okay. All right. The geometry part is kind of fun. This is kind of fun. This is neat how this works. Similar triangles. Just be aware what this means. This is the easy definition of similar triangle. You know what? You tell me. What is it? Why are those triangles similar? What about them looks similar? Well, look at those. Look at those little marks on there. Little tick marks on there. What in the world does that all mean? You ever seen that before? Okay. The tick marks are telling you. All right. If you notice, this one has 1 and that has 1. That one's got 2 and that one's got 2. That was 3 and there's 3. Okay. What they're telling you is that the angle on this bottom left triangle, part of the triangle, is the same angle measure as that. Let's say it's like, I don't know, 50 degrees or something like that. Well, this is also 50 degrees. And they'll go, oh, this is, 95 degrees. Oh, look, that's also 95 degrees. And this will be, oh, that's 45. Oh, that's 45. Okay. If you have two triangles, they all have the same 3 angles, then what's going to happen is they're going to be exact proportions of each other. In other words, they could, like, I don't know, let's say they covered this up and then they covered that up. And they said, oh, what is this side length? And what is that side length? And they go, wait a minute. You look and you go, okay, well, all the angle measures are exactly the same. Oh, so these are similar triangles. It's the same triangle except blown up or, shrunk down or whatever. Okay, so they will tell you one side that you go, oh, look, this side is 6 and this side is 3. So what is this side and what is that side? Okay, well, if you look at this and you go, okay, hang on. 6 is twice what 3 is. So this side here is going to have to be twice what 4 is. Or in other words, you could go, okay, 6 is to 3 as the same thing as is, x is to 4. Okay, so that to that is that to that. You can just, you do it exactly. Or, by the way, and of course you could see that this is, twice 3 is 6, then twice 4 is going to be 8, right? Here's another crazy thing. If you didn't do it this way, you could also go like this. You could go, oh, okay, you could go 6. I'm going to keep on this triangle first for my fraction. 6 to this, I don't know what it is yet, but I know it's, you tell me, look at it. 6, okay, the top right to the bottom is 6 to x. What numbers go into these parts of the fraction right there? 6 to this is 3 to 4, right? That should match. You just match it whatever way you want, okay? Remember how you cross multiply these things? Okay, so x times 3 is 3x. That's going to equal 6 times 4 or 24. 3 times what gives you 24? 8, just like we said a second ago. Same thing. Okay, that's all some of the triangles are. And they won't all be perfectly easy, you know? I mean, you might have to go, okay, I'm going to set this fraction up. Let's say this is like 7 and this is 3. You could go, and so this not all be integers. So you could go, okay, 7 to 3. So in other words, right to right is, I don't know what that is, x to 4. Okay, x to 4. So you go, okay, 7, wait, this to that. Top right to top right is bottom to bottom. Top right to top right, bottom to bottom. Okay, I got it. All right, so 3 times x is 3x. 7 times 4 is 28. So x is equal to 28 over 3, or like 9 1/3. They won't all be integer answers, but make sure you have a method. The method is, look at the two triangles, go boop to boop is to or you could go, you could go this to this is this to this, or you could go this to that is this to that, or whatever. Just make sure that it matches exactly from triangle to triangle, or on the same parts of the triangle to the other same parts of the triangle, just like you do. Okay, you'll see this in a second. All right, find x and y. And the answer is, there they are, right there. Okay, next problem. No, okay, I'm just kidding. All right. Yeah, let's try to find what these things are. I mean, we can make some nice little fraction things, right? You do it however you like, whatever you want to do, whatever makes you happier. I mean, you can do this to this or whatever. Let's say, for example, you looked at this little triangle and you went, okay, well, 2 to 4, in other words, left to right equals left to right. You could do that if you wanted to. Or you could do, right one triangle to right other triangle is left triangle to left this triangle. Whatever. As long as you're consistent, you're okay. Just set these suckers up by doing this. Whatever. I don't know. Let's go 2 to 4. In other words, left to right is equal to left to right. That equals 3 to x. There we go. So 2 times x is 2x. That's going to equal 4 times 3 is 12. So x equals 6. Boom. There you go. And by the way, this makes logical sense, right? Because this side here, 4, is twice what that side is. Just like this side here would be twice what that side is. Whatever. You can probably say the same thing here. You go, oh, wait, this is 5, that's going to be 10. You're right, it's going to be 10. But let's just do it the ratio way. So we could go like this. Pretend this is a fraction right here. 2 to 5 matches up 3 to y. So let's do it. 2 to 5 is 3 to y. So 2 times y, 2y. That equals 3 to 5. Wait a minute, that ain't right. Oh, I see what I did. Yeah, I am correct. I am correct. This is going to be a little bit different. Okay, so 2y equals 15. So y is going to be 7.5. And the reason I said, oh yeah, that was twice a minute ago, that was incorrect. But I just figured that 2 to 4 would be, this is going to be twice what that is. But this here, the 6, was 1.5 what this side is. Just like 7.5 is 1.5 what 5 is. I mean, don't worry about that. Do the method, take either two sides of one triangle and then make it equal to a fraction of the two exact other sides of the same triangle written the same way. Or you can go, one side of a triangle over that side of the triangle. In other words, you could go like this. 2 to 3 is equal to, in other words, 2 to 3 is equal to, 4 to x. 4 to x. Now if you notice this is like the same thing over here. Because 2 times x is 2x equals 12. Same thing we got over here. It'll be 6. Okay. All right. Use the method. Okay. Try the practice problems on page 207 and see what you get. All right. Let's take a look at the first one here. I don't like the way this looks, so I'm going to go ahead and rewrite this baby here is 7 over 4 over 2/3 is equal to 5 1/4. That's 21/4 over x. There we go. Okay. So let's cross multiply. 7/4 x equals 2/3 times 21 over 4. I'm going to go ahead and kind of take this over here. Oops, I did that wrong. 2/3 times 21 over 4. I'm going to cancel this thing out. So that's going to be 2 at the bottom. And then 21 and 3, that's going to be 1 there. And then 7. So I have 7 halves here. So 7/4 x equals 7 halves. All right. Multiply both sides by 4/7. And 7's cancel, and 4 on top, divided by 2, x equals 2. There we go. All there is to it. Okay. Pause it and try B. Okie doke. Let's try it here. We got 13 over 4 divided by P is equal to 2 and 1 6, 13 sixths, divided by 32 tenths. Yuck. I hate fractions. This should be reduced, by 2's, but we'll leave it for right now. Okay, 13 over 6 times P is equal to, I'm going to put this thing over in the corner here, 13 over 4 times 32 over 10. I'm going to start slashing here. Okay, so I'll go 4 here and 32, that's going to be 8. So I'm going to go ahead and keep going. 8 over 10, if 2 goes into both of those, that's 4 times and then 5 times. So this is going to be 13 times 4, or 52. 1 times 5 is 5. Boom. Okay. Well, we just, multiply by the reciprocal again. So times 6 over 13. I don't know if you noticed this or not. A lot of times Saxon contrives these problems so they kind of work out and cancel. 52 is a multiple of 13. So, even if you didn't see that, I don't know. That might be tough to see, but it is a multiple of 13. I would go ahead and reduce that first. So 13 goes into 13 once, of course, into 52 4 times. 4 times 6 is 24, and 5 times 1 is 5. Okay, all right. Let's do the geometry part. Go ahead and pause it, get M and P, and then, set up your nice ratios, and I'll just do one at a time, so pause it. Okay, I just decided to do M first. I don't know, it doesn't matter. What I can do is I just want to make sure you understand this. I can go like this. As long as it matches perfectly, and I have an equal sign, and I have another fraction that matches perfectly, either way you do it, it's fine. In other words, you could go like this. You could go, okay, my first fraction is 5 to 4, because they're both left side of the triangles, right? 5 over 4, and I'm trying to find M. The left to left is top to top, right? So that'll be 9 to M. Right? Okay, so 5 times M, 5M. 4 times 9, 36. M is equal to 36 divided by 5. There we go. Boom. Now, just to show you, you don't have to go from one triangle to the other triangle. You can just go from one triangle to the same triangle. You could have also done 5 to 9, and I'll stop right there. You tell me what goes in those blanks. Left to right. 5 to 9 is left to this, match is boom 4 to M, right? It matches. If you do the cross multiplication, you'll see again, you got 5 times M, just like you did here. You have 9 times 4, just like you did there. Same thing. So that's what M is. M is 36 over 5. Okay, let's clear this out. Well, you know what? I'll just use a different color here. All right, let's try to find what P is. Okay, same old thing. I got 5 to 7. Left to bottom is left to bottom. So 4 to P. So 5 times P, 5P. 7 times 4, 28. So just divide by 5. There you go. There's P. Okay. All right. You guys have a great day. See you next time. Take care. Do a good job today. 25 right or more, okay, if you can. See ya.